Okay. And also, if you want to maintain data dictionary, the cost is also very high. Means data dictionary means it is also one of the software. To be frank here, actually it is also one of the software. So cost is also very high. These are the disadvantages actually. Okay. This is about the data dictionary concept. Like now coming to the indexing methods. Okay, so already we know that in the file organized system, indexing sequential organization will be there now. So there I said so any textbook also, any record also, we are maintain the index there. Okay, so through the index, so what is the benefit means here, you can use it, you can easily access the data, the file record number or bucket number. If you know that, you can easily access that. That is the indexing. So see here. So in index DBMS also, example wise given the structure here, one search key will be there. And the search key will be how you are finding data. How the search key will be used means using data reference. Data reference means that particular bucket number, the particular record number, if you are having. Reference means what? Address now. Okay. If you know that the data address, if you know the data particular place, using the search key, you are trying to access the data. That is about the indexing database. So in this indexing, now he given two types of indexing methods we are having. Okay, one is the ordered indices and unordered maybe. Okay, so in ordered, again he given primary index and sparse index will be there maybe. I think 1 second, I will show the diagram here. So diagrammatically see here. Indexing method, we are having ordered indices, primary index, clustering index, and secondary index. Okay, so once again see, we are having ordered indices, primary index, clustering index, secondary index. Again, the primary index, we are having two types here, dense index and sparse index. Okay, so now see here once again. The indices are usually stored to make searching faster. So why we are using the index methods means to access the data fastly, to search the data fastly. That is the main purpose. The indices which are sorted or known as ordered indices means what is telling, if we are having 10 buckets of the records, okay, then that will be stored like some ordered format, 1 to 10, 1 to 20, 1 to 100, okay, sortedly. Then that is called as the ordered indices. For example, suppose we have an employee table with thousands of records and each of which is 10 bytes long, okay. Means what is telling, employee data will be there in the thousands of people, thousands of employees data will be available, and the complete table will be occupied the 10 bytes long. I mean, you people know the in C programming, integer, short int, long int will be there now. Okay, that much of the data they can be occupied there. So if the ID start with the 1, 2, 3 and so on. So what is telling here, in employee table, employee ID, employee name, salary, department. Okay, like this we created the table. Okay, so the employee IDs will be arranged by the orderly, not unorderly, not randomly. Okay, if they are maintained the sequential order, then that is called as the ordered indices. Then if you want to try to access the ID number 543, so already you are arranged already order wise. So automatically, where is the 543 will be means after 542 or before 544. Like this, you can easily access that particular index. So in the case of a database with no index, we have to search the disk block from reaches 543. So what is telling, if the indices are not there, then how should you can search the database there? Okay, then he given, so we should go to that block particularly. Then it's a very risky, actually it will take the long process. Okay, so that's why if you are maintain the ordered indices, then you can easily find out the data. So the DBMS will read the record after reading 543 into 10 means how much data it will be taken. Actually, he is actually calculating the data how much data, how much bytes of memory, how much data they are taking means 543 into 10 is 5430 bytes. Okay. And in the case of index, we will search using index and the DBMS will read the record after reading 542 into 2 means 1084 bytes, which are very less compared to the previous case. So what he's telling actually, if the indexes are not there, then it will be take the more data, more bytes of memory. If you are finding the indexes, then you are easily find out the this where the record will be stored, and also memory will also take in the less memory because bulk of memory will be available in the disk secondary storage. Okay, so in the secondary storage, if you are maintain the records in the ordered wise means they can occupy the less storage. Then what happened, how much buckets you want to store, how much records you want to store continuously you can store. If you are not properly stored means in some place some data, in some place some data, in some place some data means unnecessary the data, the memory will be losses. Okay, wastage will be happens. That is example he given. Now coming to the in order indices, we are having types of primary index and sparse index. So first of all, primary index will be there. So in the primary index, see, if the index is created on the basis of primary key of the table, then it is known as primary indexing. So whatever the index, for the index, if you are applying the primary key, so generally see primary key means what? Uniquely identified data. And for whom we are applying the primary key means there is the all are the non-unique means unique data will be there. Not repeated data will, no repeating values will be there, then we can apply the primary key. So these primary keys are unique to each record and contain 1:1 relation between the records. So what he's telling here, primary key means what? 1 to 1000. So 1, 2, 3, 4, 5, 6. Continuously the numbers will be going. There are no repeating numbers will be there. There are no repeating IDs will be there. So for that you can apply the primary key. Using the primary key, you can easily access the data. So now coming to primary index, again two types we are having, sparse index and dense index. So that one diagrammatically is shown here. So indexing method, we are having different methods here, order indices and primary index and clustering index and secondary index. And again, the primary index, we are having the two types here, dense index and sparse index. So now see the dense index. The dense index contains an index record for every search key value in the data file. So it makes searching faster. So using the dense index, what happened? It is also for using purpose to find the fasterly, to search the record fasterly only. And in this also they can be maintained the index record. Okay, and every index record having the every search key value using that. So now you can see the example in this table. So here we are having index method here, indexing number UP, USA, Nepal, UK. So now beside table you can see. So in UP, USA, Nepal, UK. So UP will be available Agra. So how much population will be there, and USA in Chicago. Okay, so there are how much people will be there, Nepal, Kathmandu, okay, and UK Cambridge. So now separately, first table you can see here. So 1-to-1 relationship they are maintaining. Means every search key will be having the, so every record, every attribute, okay, or you can say every record. So every record is maintained every search key. So UP can find easily UP, and USA can find USA, Nepal can find Nepal, UK can find UK. Like this, we are finding the data using dense index. And also here what is telling, needs more space to store index record itself. Here you are having so easily one by one you can store data in the disk. In the secondary storage, you can store data. Now coming to the sparse index. In this method, when the size of the table grows, the size of mapping also grows. So in the sparse index, automatically, if the bulk of amount of data if you are storing, then bulk of amount of you need the memory. Bulk amount of memory you need here. So these mappings are usually kept in the primary memory so that address fetch should be faster. So generally, In the, he is telling in the primary memory only the data will be storing. So the mapping also. Mapping means what? Here see UP mapping UP, USA mapping USA like this. Okay. So the mapping will be going in the primary memory, and the secondary memory will be searches the actual data based on the address got from the mapping. So whatever the mappings will be there, that can be matches to the secondary storage device. Means actually the permanent data will be stored in the secondary memory only. This thing we know that. Okay. Memory will be two types we are having. One is the primary, one is secondary. In primary means what will be there? RAM and ROM. And RAM means whatever the currently data you are doing, currently work you are doing, that will be going to store in the RAM. And secondary memory means secondary store device, hard disk, floppy disk, compact disk. These all will be stored the permanent data here. Okay. So what is telling in the sparse index? So whatever the currently which record you want to be searched, that directly connect with the secondary memory. So automatically it will be finding the which record you want to be trying to retrieving. That is about the sparse index. So all the indexes will be why we can use in means here to search the record only. Okay, fasterly you whatever the records, whatever the files you store, you want to be access that files. So that purpose only we are using this all type of the indexes here. Now coming to one of the method we are having clustering index. Okay. Now see the cluster index can be defined. It is also as an ordered data file only. So cluster also ordered only, and primary index also ordered, and ordered indices also all are the ordered. They are all are the maintain the ordered only here. So sometimes the index is created on non-primary key columns, which may not be unique for each record. So in the cluster, what is telling? So we are not following the primary key here. So when we give to the primary key, key means here for the unique data. Okay, no repeating values will be there. For that only you can apply primary keys. Okay, so what happened here? Maybe here repeating values will be ordered will be there, but in the ordered only maybe repeating values will be there. For that purpose we can't apply to the primary key. So in the cluster index is what? A non-primary key index. This is a non-primary key index. Okay, so which that only telling here which may not be unique for each record. So in this case, to identify the record fasterly, we will group 2 or more columns to get the unique value and create the index out of them. So this method is called as a cluster index. The records which have similar characteristics are grouped and indexes are created for this group. So example, see, suppose a company contains several employees in each department. So suppose we use a clustering index where all employees who belong to the same department ID are considered within a single cluster. And index pointers point to the cluster as a whole where department ID is there. So so see here how they are given. Department ID will be there. Okay. Then pointer means what, ma? Pointer. Pointer is nothing but the address. It can be stores address of the another location and the variable address. Okay. So in the cluster index, department ID number 1 is pointed to the records. So in the record, you can see 1, 1, 1, 2, 2, 2, 2, 2, 2, 3, 3, 3, 4, 4, 5, 5, 5. Means repeating values will be there. Record numbers will be repeating in this. So before in the dense index, in the sparse index, what's happening there? The repeating values will not be there, and we are applying the primary key. But in this, we can't apply primary key because here repeating values, the record numbers will be same here. That's why. So this is the way to find the records in the clustering index. This is the one of the example. Okay, and see here. So the previous schema is a little confusing because one disk block is shared by records which belong to the different cluster. If we use a separate disk block for separate clusters as shown in figure. So see department ID and pointer. So 1, 2, 3, 4, 5. So one can be belongs to all ones. So in this, what happened? Here the 1 also belongs to 1 and 2 also belongs to, the first bucket. In the first bucket, the records will be 1, 1, 2. And second bucket, 2, 2, 2. And third bucket, 3, 3, 4. And fourth one, we are having a 4, 5, 5, 5. So here he is doing here all ones can be in one bucket. 1, 1, 1. Then 2, 2, 2. Then again, if because here see 4 records will be in one bucket. 4 records will be stored in the one bucket. So the next will be going to the third record. So then again the next bucket. So 1 can be matches to all ones. 2 can be going to 2. 3 can be going to 3. Like this, the clusters will be searching the records here. So one more we are having here, secondary index. So now coming to the indexing methods we are having. Once again I'm telling, ordered indices, primary indexes. Now primary indexes we are having the sparse index and dense index also. And now coming to the next we are having cluster indexes. Next we are having the secondary indexes. Now see secondary storage. In the secondary index, what will be happening here? So to reduce the size of mapping, another level of indexing is introduced. So whatever the records will be there, to reduce the size, we can use the secondary index here. So in this method, what's happening here? The huge range for the columns is selected initially, so that mapping size of the first level becomes small. So what is telling here? So we are taking the huge range of the columns. So see here given the diagram also here. So each range is further divided into smaller ranges. The mapping of the first level is stored in the primary key so that address fetches faster. The mapping of the second level and actual data are stored in the secondary memory. So now see, here we are having roll number 100, 200, 300. They all are in the primary key. In the RAM, the storage is the. So it can be, the 100 can be pointers to the first bucket. In the first bucket, we are having 100, 110, 120. And then now coming to 200. So in 200, 210, 220. And coming to 300, 300, 320, 310. So this all will be here secondary storage devices, hard disk. Now coming to the data block in memory. So in the memory, how it will be there. So again 100, 101, 110, 111. So 110, again 110 will become 120, 121, 200, 201, 210, 211, 300. So see what is telling here. So for example, if you want to find the record of 11 in the diagram, roll number 11 in the diagram, then it will search the highest entry which is smaller than or equal to 11 first. So what is telling here, see, first of all, your record number will be 111. Okay, so 111 will be available where actually after 110, the 111 will be coming. So first we are have to, the main primary in the RAM, what will be there? 100, 200, 300 will be there. So first of all, 100 to 200 we should go. So 100 can be points the 100. So this will be available secondary. So again the internally memory block will be, it again separated the secondary level. So in second level 100 to 101, so here see 100 to 110. So again divided the 100 to 110. So after 110 we are having 111. So like this, where is the 111 will be there means in the second bucket. So in the secondary access method, you can find the address. This is the way. So see here. So which is smaller? Smaller than or equal to 11 in the first level index. So it will get 100 this level. So then in the second index level again it does maximum. So he is comparing the records. Which record you want to be searched? Nothing is there. Okay. Which record below 100 or after 100 or below 110 or after 120. So where you want to be searched, according to that using your search key. Okay. Then you can find the index. So how the records will be separated in this clustering method, you can check. You can see in the diagrammatically. That only he's telling. So these are the indexing methods. Okay. Now next to you, next. What will be there here? Yeah, so this is another important question. I mean, important concept here. Database transactions. Database transactions. So see here. So generally, we people know that transactions means what? Employee table will be there. There you want to be employee. Given the example, employee table or student table. So there you want to modify the data, update the data. Transactions means what? Generally, we people know the bank account details. Okay, means you want to be deposit your money, you want to be withdraw your money. So we know that these are the transactions. So in the database, any type of data, if you want to add data, if you want to delete data, if you want to modify data, these all are also we call as the transactions only here. So now see basics of transactions. So transaction properties will be there actually. Yeah. So we are having 4 types of properties here. Acid properties. We simply call as acid, ACID. Atomicity, consistency, isolation, and durability. These are the 4 properties we are having for transaction. Transaction properties means acid. You can remember the word acid, atomicity, consistency, isolation, and durability. Okay. Now, atomicity. So example he given, see here. This means that either all of the instructions within the transaction will be reflected in the database or none of them will be reflected. Say, for example, we have 2 accounts, A and B. Each contain 1,000 rupees. We now start a transaction to deposit 100 rupees from account A to account B. To give better performance, every database management system supports the execution of multiple transfers at the same time. Okay, so using CPU time sharing, concurrently executing transactions are trying to read and write at the same time. So what is telling here, atomicity means here, atomicity means from A is the one account, B is the one account. In the A account, you are having 1,000 rupees, and in the B, so from that 1,000 rupees, you want to transact the amount 100 rupees to the B. So what will be happen? So how much you want to be transferred to the B account, that much amount only transferred. Okay, means so there any errors will not be occurred, any reflections will not be occurred. Then that is called as the atomicity. And he is telling here about multiple transactions only. Means A to B, B to A. Simultaneously means I want to send the money to people, you people, and you want to send to me. So you are doing your transactions, I am doing my transactions. Both are doing our transaction. Concurrently, we are doing. Okay. So but no errors will not be occurred here. That is called as the atomicity. And again, one more example is given. See that, for example, we may have a table or a record on which two trans are trying to read or write at the same time. So generally, see, read and write. You people know the difference. For example, one CD will be there. Okay. So in the CD read. Read means whatever the information available in the CD. That may be movie, that may be any PDF. That just you can read that. You can't modify that. That is called as a read. Write means what? So you want to be changes that you want to be installed, you want to insert data, you want to modify that, modify the data. That is called as the write. So he's telling here both operations, read and write, both operations if you want to try to do on the both accounts at the same time concurrently, if you want to do multiple transactions, that is called as the atomicity, and there will be no violations will be not occurred. That is called as a atomicity feature. Okay. Now, next we given about the isolation. So see here, isolation also same, that will only coming. So in case multiple transactions are executing concurrently and trying to access a shareable resource at the same time, the system should create and ordering in their execution so that they should not create any anomaly in the value stored at the shareable. So, hey, after 6 o'clock. So, here, see, ma'am. Actually, we are telling about the isolation. So, isolation means just before what example I given. So, both are doing the transactions here. Any type of violations, mean any type of anomalies will not be occurred. So, there only means in the internal CPU also, in the database also, no problem will not be occurred. Okay, no two sides also. That is also, again, he given the isolation only. So, atomicity also he given like this only. Isolation also like this, and he is not explain about the consistency means what. Generally we know that the consistency means consistency means just before how much amount you are transferred, that much only. Sometimes what happened, okay, if you are trying to withdraw the money 3,000, okay, but the money will not be come, but in the receipt what will be coming, you withdraw the 3,000 money. So that is not the consistency way. Consistency means how much you are trying to transfer, you are trying to transactions, that will be particularly exactly will be happened. If up and downs will be going, that is not also consistency here. Okay, durability means duration. General durability means time, how much time, how many times you want to do. That is about the durability. So at here transactions rules we were having atomicity, consistency, durability, and isolation. Acid properties generally we call as. Okay, now see the again he given here basics of transactions. So see what he's giving. Suppose we have to calculate total marks of a student. Then what are steps involved in it? So see, get the marks in each subject. Say we have only 3 subjects here. So calculate the total and then display it. Here all the 3 steps are called transactions. Okay, for example, he given like this also, not about money, not about bank transactions. Like in student wise also, you can do the transaction like this way. So calculate the total and then display it. So here all these 3 steps we call as a transactions only. So these are 3 small actions. See here, first of all, get marks subject 1, marks subject 2, marks subject 3, then calculate total, then display total. So in this, what we are understanding, so if you want to find total marks means you should know all 3 subjects marks. Okay, if you don't know this subject marks, any one subject marks also, you can't total that. Okay, and you can't display the total. So means you should know all the 3 subjects mark, then you can easily find total, calculate total, then you can display the total. This is where the simple example for the transactions. Are you people are there, ma? Listening?
Yes, ma'am.
Okay, ma. Okay. So from the above example, we understand the transaction is a small piece of action, operation in the database. So generally, whatever the actions you want to be do, whatever the operations you want to be do, that we call as a transaction in the database. Okay. Now next to see. So one more again, he given about balance, about amount also. Okay. So how much? So I think whoever having some commerce knowledge, no need the commerce knowledge also here. Generally, we people know that if we are having the 5,000 amount money, so first we deposit 5,000 money, then we withdraw the 1,000. So then what happened? 5,000 minus 1,000 is 4,000 will be there. Hama. So like this, the calculations will be going internally in the database. What will be happening here? So the database internally doing some operations. That is about the transactions he is telling here. So if any type of problem will be occurred, then complete system will be going to collapse. But so they must be careful whenever who's are maintained the database. Now again he given the acid properties. Just before I said acid properties of transactions: atomicity, consistency, isolation, durability. So atomicity we already seen, we have seen that. Now once again see consistency. So already I said, but I see any transaction should not inject any incorrect or unwanted data into database. it should maintain the consistency of the database. Means whatever the transactions you are doing, that will be going to correct, not incorrect information will not be going to there. How much you want to be transfer, that much only. How much you want to be deposit, that much only available. If it's not happening, if any mistakes will be going there, that will be is inconsistency data. So in the above example of total marks, while calculating total, it should not perform any other action like inserting or updating or delete. Okay. So it should also not pick marks of other students. So what is telling? So we want to calculate the one student data, student marks means. So you should take the Esma, Chintu, don't talk here. So here means one student total you want to do means subject 1, subject 2, subject 3 of one student only you can take. Don't take the other student marks. Don't take the other students marks and you can say these are the my marks. That will not going there. Okay, that is not the correct way also. So exact whatever the correct information only if we are maintained, that is called as the consistency. Now see the durability. So the database should be strong enough to handle any system failure. So first of all, whatever database you are maintain, that will be going to strong. Means the software, so database software, many softwares we are having. Okay. So whatever the software you are maintain for database, that can be strong. So see here, it should not working for single transaction alone. It should be able to handle multiple transactions too. If there is any set of insert update, then it should be able to handle and commit to the database. Actually, you people having the commands, DCL, data control language command, rollback and commit. Okay, means how much you are going to do whatever transaction, last transactions you are going. Means in your account you have 10,000 money. So you 10,000 withdraw the money. So that much, that is the last transaction. That it will be going to show. Like in our Google Pay also we know the history of transactions. Okay, how much we are deposit, how much we are withdrawal, all transaction it's maintaining. If the Google Pay is not maintaining, means no one open that app. Okay, so now this generation we are having a lot of apps here, not only Google Pay, Phone Pay, okay, and our something, okay, Paytm, okay, many apps like Axis Bank, credit card, I mean Airtel, many we are having. Okay, so these all bankings, these all databases are maintain the correct information. If these all databases are strong, then only no failures occurred. Okay, and also they should maintain the correct time also, according time also, according data, how much, these all things if you are maintained, that is called as a durability here. Okay, now see transaction states. So transaction states that we are having active, partially committed, failed, aborted. So see in diagrammatically simply I am explaining. So generally whenever I want to transfer the money to my friend. So now I am opening my Google Pay. So now I am in active position. That is called as a active transaction. Okay, now I open that Google Pay, okay, and I selected my friend name also. I given the some amount 5,000 I want to transfer. So I partially committed. I partially committed to transfer the money, okay, from my account to my friend account. Partially committed. It's not going to successfully. When it will be going to successfully means when my friend received the money, then it is committed. Okay, so now the process is going. So whenever the process is going, it will be going loading, buffering. You people know now. That is called as a partially committed. So in the partially committed, diagrammatically is shown here failed. So when it will be going failed, if in my account the amount is not there, that time also it will be going to fail. Otherwise the mobile network is not working. Otherwise the bank server is not available. So due to all these reasons, it will be going to fail. Okay, so whenever it will be going to fail, then immediately we got the message aborted. Okay, your transaction is aborted. You want to be aborted or denied. Okay, so aborted means when the transaction is going to be aborted, That is also given the whom given here message bank only maintain the database only maintain the message here. All this instruction bank only maintain here. Okay, when it will be committed, if the in my account the amount will be there, and also there is no network problem will be there, so all will be working properly. All are the active position. Then my friend also received the money, that is called as a committed. So in the diagram, see here how many stages we are having. First of active, partially committed, committed. This is the one of the way. And second way, what we are having, active will be there, then going to fail, then going to aborted. And finally, the transaction going to end. These are the steps, or you can say the stages. Steps, or you can say stages of the transactions. Very simple to understand. In our daily life also, we are doing this, all the transactions. Okay. And now see what will be there. Concurrent execution and recoverability of transactions. 1 second, I will check the proper. So see, generally in the name only you are having the here concept here. What is he telling? Concurrent execution and recoverability of transactions. So concurrently means what? Simultaneously. Whatever transactions you want to be do, that will be going to execute it concurrently. So see here what is telling here. Transaction processing system usually allow multiple transactions to run concurrently. So multiple transactions we are doing simultaneously. So in the generally in transactions we are doing multiple transactions. We are open, we are closed. Not only myself. So in our world wise are you taken, or in the area wise if you taken, okay, bank wise, ATM wise if you taken. So many people are doing the transactions at a time. Multiple users are doing the multiple transactions at the same time. So allowing multiple transactions to update data concurrently causes several complications with the consistency of the data. So sometimes what happens, maybe database server is not working properly, or database is not a strong database. Due to some reasons, some consistency means inconsistency also will be occurred. So see, to maintain the consistency, so ensuring consistency in spite of concurrent execution of transactions requires extra work. So it is far easier to insist that transaction runs serially, that is one at a time, is starting only one of the previous one has completed. So for that, what is telling actually, so whenever we are doing multiple transactions continuously, so how we can do means one step, one after another. That time what happened, that concurrency transactions, I mean anomalous errors will not be occurred. He's telling actually one by one you should do. So now see, to maintain the concurrency transactions, we are having some steps we are having here. Improved throughput and resource utilization. So for this, he's giving here, a transaction consists of many steps here. So some involve input output activity, otherwise involve CPU activity. The CPU and the disk in a computer system can operate in parallel. So generally see here, not only bank transaction, CPU also, in system wise also, if we can take the, you open the MS Word, you open the PowerPoint, you open the music, you open the mail. Okay, so all the tasks, we open the multiple tasking means multiple works we are doing at the same time. So there internally what's happening, CPU scheduling will be there. So CPU batch processing system in operating system, you people know multitasking operating system. So there one task another after, one task after later one task, like that they are following. So CPU can maintain a CPU schedule time like that. They here also, they in this bank, not only bank, in the database also, input output devices and CPU, everyone should maintain the series here. Serial wise they should maintain here. Now see, The parallelism of CPU and the input-out system can therefore be exploited to run multiple transactions in parallel. So what he's telling, generally processing will be going into a CPU. How the process will be internal CPU only, but the data will be going to input and the output will be coming from the output device. So these are all three will be connected to each other. So they all will be parallelly working with understandingly generally. Okay, so I'm sending the data through the input that will be going to CPU. CPU can be perform the process, and from the output device we are getting the output. So these three are doing the parallel working, then no problem will not be occurred. And see here what, and one more he giving reduced waiting time. So there may be a mix of transactions running on system. So if we are performing the many transactions and the transactions will be going to, if you people are observing or not observing, phone also in the system also, if you opening continuously, if you opening, closing, the system will be going to hang. The phone also going to hang. So that type of problem will not be occur means for that purpose, you should reduce waiting time means, see here, if transactions run serially, okay, one by one, they will be going to serially. A short transaction may have to wait for a preceding long transaction to complete. So what's happening? The transaction is small task will be there, long task will be there. So the short also wait so for time for some time. The short also wait for the long transactions. So which can lead to be unpredictable delays in running transactions. If the transactions are operating on different parts of the database, it is better to let them run concurrently and sharing the CPU cycles and disk access among them. So just before I said, whatever transactions will be going, internally CPU should maintain CPU scheduling system. So which according to time requirement, so which one you perform the first, okay, that will be going to execute the first. Like if you are having data structures, queues and stacks, okay, first in, first out, last in, first out, like that. So concurrent execution reduces the unpredictable delays in running transactions. Moreover, it also reduces the average response time. The average response time for a transactions to be completed after it has been submitted. So it's explaining some about the transactions. Now seeing about the serializability. Serializability means what? So just now we are telling about the concurrent transaction means same time if you are performing transactions. Serializability means one by one, one after another means 1, 2, 3, 4 like this. That is called as a serializability. Okay, so serializability graph is used to the test the serializability of a schedule. So schedule means, see, now I think you people are in the 4th semester. So this is the my class timings this time, and you people have the some other classes also, other subjects also. You are having schedule. So in this also schedules will be there. For the transaction purpose also they maintain the schedule. Okay, so assume a schedule S. The schedule name he given S. For S we construct a graph. So graph means we know that now, known as the precedence graph. This graph has a pair G equal to, graph equal to V comma I, vector and edge. So I think V for vertices, E for edges, where V consists of a set of vertices and E is a set of edges. So the set of vertices is used to contain all the transactions participating in the schedule. The set of edges is used to contain all edges. Ti pointed to Tj for which one of the three conditions. So create a node T1 Ti to Tj if Ti executes the write queue before Tj executes read queue. So what's it telling here? Two transactions are there here. Okay, so one will be going to execute. So he given the names here. Okay, Ti points to Tj. So Ti executes the write queue. Ti execute over, then you are given to write queue before Tj execute the read queue. So Tj read and write, we know the difference. Read means just we are referring Just we are whatever the information will be there, just we can read that. Write means we want to be insert, we want to be update, we want to be modified. So read is not the biggest transaction here. Read is a short transaction, but write means long transaction. So according to that, here he given the steps here. The next point, what he given? Ti points to Tj. So if Ti executes read queue before, Tj executes write queue. So opposite he given just. The operations you can see. First he given write, then again read. Now he given read, then again write. Just that only he changes. The names also not changes here. Just the operations only changes. First write, then read, then write, then read, then write, like this. And here given the write and also write. So operations only changes here. Okay. So see here graph he given Ti to Tj like this. Ti to Tj. And T means what? Transaction 1 to transaction 2. I means 1, J means 2. I1 to T1 to T2 like this. Okay. Here given see. What I said here T1, T2. Again he given the explanation. If you people read this easily, this is the this points wise you can go. This will be you can easily understand. So you can once see check the table ma. Okay, if you are not understand, tomorrow I will explain about this transactions. Once we can go through this table. You people are having this PDF or not having?
Where I have textbook, ma'am.
Some students are not having textbooks. I think some students are not having PDF. If you are not having, I will share in the group this PDF also.
Okay, ma'am.
Please share the PDF,
I will share the PDF, ma'am.
Yeah, I will share that PDF, ma'am.
Okay, ma'am. Thank you.
Just before we discuss about the I said that na data control language. So commit, rollback, save point. Okay, this so okay, this point. What next? Structure query. Okay, commands only we are having. Okay, this topic will be there, Namma here. See here, this one. Definition of transaction in the SQL. So this also will be comes in the SQL only. Okay. So in the SQL, I will explain the DDL, DML, TCL, and DCL. All the 4 types of commands I will explain in this unit only. Okay. So tomorrow we are having a class now. So tomorrow I will explain. This is the and inform to all your friends. And this is the going to practical. Actually, up to now we discussed about the theoretical only, but actually these all are the completely practical commands. I said now. To create database, we are having the commands. I said DDL, DML, TCL, DCL. So all these commands, practical knowledge he given, how you are creating table, how you are updating, how you are modifying, how to rename the table, how to change the logical structure. All these are we are having here commands. In this unit you are having, and this is the very most important unit also, practical knowledge. So if you know the practical knowledge, then that is will be easy. And this primary key, foreign key also, again, we discussed already, but again he given, okay. So inform to your friends. Okay, tomorrow I will join the at sharp 4:30. Actually, I forgot. Actually, I came from some other place. That's why I forgot, ma. Sorry for that delay, okay.
Ma'am, give me the important questions, ma'am.
Yeah, I will share. Actually, I am outside, ma. So tomorrow I will share.
Okay, ma'am. Thank you, ma'am.
Okay, ma'am.
Okay, ma'am. Bye. Take care, all of you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
You're welcome, ma.
मकरन नहीं हरारत होती है
तो क्लास क्लोज करना है अच्छा है सुपर अब अच्छा है क्या हुआ
हेलो नहीं आ रहा गूगल में जा गूगल में थे
जूम
जूम क्लोज कर जूम
खराब हो जाता फिर